What is the scope of variables in JavaScript? What is the scope of variables in JavaScript? Do they have the same scope inside as opposed to outside a function? Or does it even matter? Also, where are the variables stored if they are defined globally? TLDR. JavaScript has lexical, also called static, scoping and closures. This means you can tell the scope of an identifier by looking at the source code. The four scopes are: global, visible by everything; function, visible within a function, and its subfunctions and blocks; block, visible within a block, and its subblocks; module, visible within a module. Outside of the special cases of global and module scope, variables are declared using var, function scope, let, block scope, and const, block scope. Most other forms of identifier declaration have block scope in strict mode. Overview. Scope is the region of the code base over which an identifier is valid. A lexical environment is a mapping between identifier names and the values associated with them. Scope is formed of a linked nesting of lexical environments, with each level in the nesting corresponding to a lexical environment of an ancestor execution context. These linked lexical environments form a scope chain. Identifier resolution is the process of searching along this chain for a matching identifier. Identifier resolution only occurs in one direction, outwards. In this way, outer lexical environments cannot see into inner lexical environments. There are three pertinent factors in deciding the scope of an identifier in JavaScript: how an identifier was declared, where an identifier was declared, whether you are in strict mode or non-strict mode. Some of the ways identifiers can be declared: var, let and const, function parameters, catch block parameter, function declarations, named function expressions, implicit variable declarations, import statements, and eval. Some of the locations identifiers can be declared: global context, function body, ordinary block, the top of a control structure, for example loop, if, while etc., control structure body, modules. Declaration styles. var. Identifiers declared using var have function scope, apart from when they are declared directly in the global context, in which case they are added as properties on the global object and have global scope. There are separate rules for their use in eval functions. Let and const. Identifiers declared using let and const have block scope, apart from when they are declared directly in the global context, in which case they have global scope. Note: let, const and var are all hoisted. This means that their logical position of definition is the top of their enclosing scope, block or function. However, variables declared using let and const cannot be read or assigned to until control has passed the point of declaration in the source code. The interim period is known as the temporal dead zone. Function parameter names. Function parameter names are scoped to the function body. Function declarations. Function declarations have block scope in strict mode and function scope in non-strict mode. Note: non-strict mode is a complicated set of emergent rules based on the quirky historical implementations of different browsers. Named function expressions. Named function expressions are scoped to themselves, for example for the purpose of recursion. Implicit variable declarations. In non-strict mode, implicit variable declarations have global scope. In strict mode these are not permitted. Eval. In eval strings, variables declared using var will be placed in the current scope, or, if eval is used indirectly, as properties on the global object. Examples. The following will throw a reference error because the names x, y and z have no meaning outside of the function f. The following will throw a reference error for Y and Z, but not for X, because the visibility of X is not constrained by the block. Blocks that define the bodies of control structures like if, for and while, behave similarly. In the following, X is visible outside of the loop because var has function scope. Because of this behavior, you need to be careful about closing over variables declared using var in loops. There is only one instance of variable X declared here, and it sits logically outside of the loop. The following prints 5 times, and then prints 5 for and 6th time for the console log outside the loop. The following prints undefined because X is block scoped. The callbacks are run one by one asynchronously. New behavior for let variables means that each anonymous function closed over a different variable named X, unlike it would have done with var, and so integers 0 through 4 are printed. The following will not throw a reference error because the visibility of X is not constrained by the block. It will, however, print undefined because the variable has not been initialized, because of the if statement. A variable declared at the top of a for loop using let is scoped to the body of the loop. The following will throw a reference error because the visibility of X is constrained by the block. Variables declared using var, let or const are all scoped to modules. The following will declare a property on the global object, because variables declared using var within the global context are added as properties to the global object. Let and const in the global context do not add properties to the global object, but still have global scope. Function parameters can be considered to be declared in the function body. Catch block parameters are scoped to the catch block body. Named function expressions are scoped only to the expression itself. In non-strict mode, implicit variable declarations are globally scoped. In strict mode you get an error. In non-strict mode, function declarations have function scope. In strict mode they have block scope. How it works under the hood. Scope is defined as the lexical region of code over which an identifier is valid. In JavaScript, every function object has a hidden environment reference that is a reference to the lexical environment of the execution context, stack frame, within which it was created. When you invoke a function, the hidden call method is called. This method creates a new execution context and establishes a link between the new execution context and the lexical environment of the function object. It does this by copying the environment value on the function object into an outer reference field on the lexical environment of the new execution context. Note that this link between the new execution context and the lexical environment of the function object is called a closure. Thus, in JavaScript, scope is implemented via lexical environments linked together in a chain by outer references. This chain of lexical environments is called the scope chain, and identifier resolution occurs by searching up the chain for a matching identifier. Thanks for watching. Subscribe to learn JavaScript. We have a number of awesome tutorials in the works.